Today we will talk about Anova, or analysis of variance. I will cover one-way Anova to test the hypothesis that 4 population means are equal. You can do that to K means. In other words, you can test more than 4, but the example that I'll give is going to be for 4. You have to make a couple of assumptions. The populations have to have normal distribution, and they have to have the same variance, and the samples have to be simple random samples. So you set your H null and H1 this way. H null meaning all the population means are the same. H1 meaning one mean can be different. Now let's look at the data. I have some deceleration data for different size cars, and we are going to use 0.05 significance level to test the null hypothesis that different weight categories have the same mean. So you set your H null as the mean from subcompact, compact, midsize, and full size are the same, and H1 being different. Now, the formulas for test statistic are very complex and long, so I will go straight to the TI-84. For the test statistic, you can go and get the variance between samples and variance within samples and compare the F to F critical. Actually, when you do your TI-84 calculations, the F will be also displayed for you if you want that intermediate step. So you start by entering stat, edit, the 4 data sets, and I did that for you ahead of time. L1 has the subcompact, L2 has the compact, L3 the midsize, and L4 has the full size data. You enter it by going stat, edit, and then use the up and down arrow key and type those in. Now, when I want to do the analysis one-way Anova using the TI-84, all you have to do is you have to go to Stat, Test, and Anova is built in. If you scroll down, it's the last choice, H, Anova, and you pick it by entering. And now you have to tell where you want to take the data from. L1 is one, L2 is the second one, L3, and L4. That's it. It will display all these intermediate steps, but the one that you're interested in is the p-value, and this one is 0.296, and that is, and it also displays the F value. You can, the F of 1.34, and you can compare that to your F critical, but the p-value is the easiest method, 0.296, and you compare it to your alpha, which is 0.05, and p is greater than alpha. That means you are outside the critical range. So that means there's not sufficient evidence to support the claim that larger cars are safer. So that's the end of our analysis for Anova, one-way Anova. If you want to enter more data and do this analysis, and TI-83 and 84 makes it very, very simple for you.